I'm Tim Ventura, and we're joined today by David Harary, a senior analyst with Agensys Corp, and Booz Allen Hamilton, working for the Office of the Deputy Chief of Staff for Operations of the Air Force at the Pentagon. David has built his experience around space-based remote sensing programs at NASA, the National Oceanic and Atmospheric Administration, the U.S. Department of Defense. He was named one of the top 20 under 35 by Space and Satellite Professionals International. He's participated in numerous professional boards and advisory groups, and he's written articles appearing in publications such as Just Security, The National Interest, the Bulletin of the Atomic Scientists, Slate, the Jerusalem Post, and the Woodrow Wilson Center's News Security Beat, among others. He joins us today to discuss the applications of remote sensing in today's rapidly changing world. So David, welcome. Let me start out by asking you to help our audience with a solid definition of space-based remote sensing. Is this synonymous with what we might think of as satellite surveillance? And can people visualize this for themselves as essentially taking photos or video of the ground from orbiting satellites?
Well, Tim, first, let me say thank you for having me on. I'm absolutely thrilled to have this discussion with you to talk a little bit about this nexus of climate security and its relationship with these new emerging technologies, that is space-based Earth observation and satellites for remote sensing purposes. So when we talk about remote sensing satellites, what we really mean is cameras and different kinds of sensing tools. Some examples might be LiDAR, radar, in addition to visual optics of looking at the Earth and sensing the Earth from space. Now, remote sensing, as that phrase unto itself, can mean a very broad range of different technologies. Remote sensing really just means to observe and to gain data on an object that is not immediate to the sensing tool. So some examples of remote sensing tools, not just satellites and not just cameras, for example, from space, they could also include things like X-rays or MRIs, objects and sensing tools that are quite close. So there's a really broad range of different applications that can be used under the umbrella term that is remote sensing. Now, when we talk about remote sensing satellites for the purpose of environmental security and monitoring environmental conditions and weather, there are a variety of different tools and applications and sensing technologies to be able to do that.
Okay. Well, so let me jump into your background. Now, your resume is impressive, and it begins with internship roles in both the United States House and Senate, with later work moving into climate research at NASA, NOAA, and several other prestigious organizations. What led you into space-based remote sensing, and what is your primary focus in that area?
I really appreciate this question, and I definitely did not get into remote sensing just immediately. I had to come at it from learning about a variety of different other topics, and I did that specifically in college, because colleges are just a great path and avenue to be able to learn about a variety of different subjects. And I was a student in college at the University of Buffalo, and I took a variety of different courses in economics and earth system science. And one of my favorite courses was a soils management course. And this course, we got to understand everything there is about the different layers of soil, about the soil moisture content, for example. And we would get out into the field and do these lab experiments, digging holes in the dirt. And we would see at how far down is the water table. What are the different components of the soil, whether it be clay or silt or sand. And it was around that time that I had happened upon a NASA research YouTube video with a professor named Molly Brown. And she was describing a new satellite that NASA was sending up to space at the time. This is back in 2013, called Soil Moisture Active Passing, otherwise known as SMAP. And this special satellite would go up 200 miles up into space and would orbit the Earth 14 times a day. And from that elevation, it would be able to gather a whole wide range of characteristics and data on soil around the entire Earth. And here I was in class, digging into the dirt, digging up these soil profiles by hand. And yet there's a satellite going up into space that can measure many of the characteristics that I was doing by hand 190 miles up in space. And it can do that throughout the entire globe. And so all terrestrial land on the Earth would be able to be monitored by the satellite. And I said, holy cow, that's incredible. And if there's just this one satellite that's looking at specifically soil and moisture, how many other satellites and how many different sensing tools might there be that can gain all kinds of characteristics and data on the atmosphere, on the environment, on ocean systems, and so forth? And then can you make predictions and forecasting probabilities based on that data? And this really opened my eyes to the emerging technologies that is space-based Earth observation.
Oh, okay. Well, so now you're in kind of an intersectional area with this, right? Because you're working for the Department of Defense right now. So I wanted to touch on some of the defense applications of this technology, even though your focus is more on the climate area. So let me start out by asking, again, from a defense perspective, do you think it's accurate to say that the transition to satellite surveillance is what led to the demise of kind of the Cold War era, right? Of the spy planes? We used to have the U-2 and the SR-71. And do you think that when that transition happened, and I believe one of the first satellites went up back in the 50s, right? But I think it was like the 70s and 80s where it really started to pivot. Do you think that started to drive further innovation that led to today's space-based sensing technologies?
I definitely do. The applications and sensing tools that were provided by agencies like NASA, like NOAA, USGS, these are civilian scientific agencies that are not the Department of Defense. And back in the 70s and 60s, they started providing environmental data to everyday people, to everyday citizens, and not just those in the United States, but around the world. And this data would be used for all kinds of scientific research purposes, as well as providing critical weather data to people all over the planet. And so that definitely marked a transition from these satellites and these sensors primarily being used by military organizations and intelligence communities. I would mark another transition point in 1991. George H.W. Bush signed a new law that allowed and opened up the use of remote sensing technologies, especially those in space, to commercial entities and not just public agencies and government agencies. And that marked a real transition point that started, I would refer to it as a geospatial revolution that would kick off all kinds of new startups and companies and the creation of new ways to analyze and assess the Earth. And that was really the GIS revolution, I would refer to it as. And I would say that really kicked off and was really jump-started by that landmark new policy that, again, George H.W. Bush signed into law in 1991.
Okay, so this innovation not only did you mentioned the GIS revolution, not only has it been going on for a while, but it's still continuing, right? And so I think advances in computing and processing power, that's obviously that's kind of a gimme in terms of something that assists. But I recently read about another innovation that AFRL is working with, something called hypertemporal imaging, where they can resolve missile plumes through cloud cover. And so I'm wondering, is technology like this an example of one of these rapid advances in technology that are really driving new innovations in space-based remote sensing? And do any other examples of breakthrough technologies like this come to mind that you're seeing on the horizon?
There's just so many different sensors and tools being developed and researched and then used, especially over the last 10 years. And it seems as though there's a new startup, there's a new GIS tool, and there's a new technology that's coming out every day. And it's especially exciting right now to be in this field because of that innovation that's so rampant. And so that's a great example of what AFRL is doing. I also definitely point to new technologies in the LiDAR space, synthetic aperture radar, SAR. That has definitely been a revolutionary area that is being developed by a number of different corporations and startups. And then there's the optical sensors themselves that are advancing, that are miniaturizing as well. So you have startups like Spire and Planet and Maxar setting up small satellites, maybe the size of a loaf of bread even. And these satellites are able to capture so much critical data on a variety of different spectrum and wavelengths. And yet the resolution can be significantly, pretty high, despite those satellites being quite small. So you have a number of different technological innovations at play right now. And of course, miniaturizing satellites is a big one. But in addition to that, it's access to space in the first place too. 20 years ago, the cost to deliver a satellite into space was maybe 2 to 3 times higher. And so now companies are able to send up experimentation research satellites and develop new technologies at a faster pace because they're able to send up more continuous satellites at a more rapid pace as well. So there's just a lot of innovation that's happening. You mentioned data and computing power as well. And that's another huge factor right there of applying artificial intelligence and machine learning to this huge swath of data. I almost say that there's too much data now in the environmental and weather field, so that analysts have maybe not enough time on their hands to be able to interpret and input that data in ways that they can understand. So there's the limiting factor there, perhaps, in the environmental security field is time, is the amount of man hours available to download that data and interpret it in ways that they can understand.
Okay. Now it's interesting, actually. You jumped ahead because orbital payload cost was my next question. I was going to ask about how that affects things, right? Because we're dropping this cost. We're dropping the cost of putting these payloads into orbit. And then another thing that you had mentioned was microsatellites, where we've got this tiny little shoebox with a big camera on it, and so it's not the big, heavy, expensive satellite of the past. Now, is that opening new doors in your area, just being able to put more sensing into space, being able to do it more cost effectively, and perhaps, especially with microsatellites, maybe not having the same concern about this long-term reliable device, right? So maybe that opens doors for more experimental approaches or something like that.
It absolutely does. And you see agencies like NOAA go through with pilot programs to be able to work with those new startups. For example, NOAA Satellites has a program called Commercial Weather Data Pilot, CWDP, and that program is to obtain data from these startup satellite companies and offer that data to the public. So there are opportunities for new partnerships, and with these new emerging technologies, and again, the cost of delivering those technologies into orbit, the access to being able to obtain that data is becoming easier. The cost of that data is becoming cheaper, and the availability of that data for GIS users is therefore it's all there for you. And even better is much of the weather environmental data, even the Department of Defense provides to its own users, that much of that data is itself actually public as well.
Oh, okay. Well, so let me touch more on climate then, because this is your primary focus area. You're doing a lot of analysis of weather and climate using this sensing technology. So I guess one thing I should start with, and this may not make friends for me in some segments, some sectors, but I realize that global climate change it's kind of a political hot button, but from the perspective of a scientist as well as a specialist, what are your thoughts on climate change, and how can this technology be used to analyze it?
So absolutely, from my perspective, climate change is happening. It's a real threat to society, to economies, as well as to security around the globe. And then secondly, climate change, I don't believe is being taken seriously enough by governments, and we need to do a lot more to mitigate this threat. And climate change is here; it's now. We see the effects almost daily, and the rising cost of extreme weather events, whether it be wildfires or worsening hurricanes, and the frequency and magnitude of those extreme weather events, it's getting worse. And if that's happening right now in 2022, my question is, what is going to be happening in 20, 30, 40 years from now? And thus, I do see these technologies, these space-based Earth observation satellites, machine learning and artificial intelligence towards geographic information systems, GIS applications, all these new innovations and technologies can be so helpful and useful towards being able to predict those environmental changes that climate change brings upon us, in addition to the climatic shifts that are changing as well. And so being able to forecast and predict extreme weather events and then make policy decisions to mitigate the impact of those events, for example, is going to be extremely critical, and it already is right now.
Well, yeah, and so let me drill down a little bit on that, because I understand that you use weather and environmental data from numerous space agencies, right? Again, we're talking NASA, NOAA, USGS, NGA, and the USSF. So you're using that to predict and forecast political instability and state competition, right, from resource insecurity, as well as extreme weather, ecological collapse, and things like that. So these climate changes are affecting people, states, governments. And so I think that's part of your role. Can you tell me a little bit about those applications?
Yeah, I would love to. And I would love to talk a little bit about maybe an example of how climate has interacted with state instability and war. So back again, when I was an undergraduate in 2011, there were reports that had come out that that there was a drought in 3 places in the world that propagated the price increase of food products, especially wheat. And the drought that had occurred specifically in China, in Russia, and the Middle East. And what we saw were incredible price fluctuations and specifically increases 700, 800% higher as a result of that drought. And what happened was Russia and China withheld their exports of wheat products and also increased the price. Now, the results and the impact of that downstream to Middle East economies and specifically cities were food riots and protests in the streets of Aleppo, in Cairo, in Algiers, in Amman. And what we saw were these protests around food and the availability of food and food insecurity propagated and sparked further riots against their own governments. And this was the beginning of what would eventually become the Arab Spring. And if we fast forward to a couple years later in Syria, this also was the original sparks that would lead to the Syrian civil war that of course killed over 500,000 people and forced over 5 million people into refugee status. Now, those droughts that occurred in the Middle East and in China and Russia were 2 to 3 times more likely because of climate change. And so we have already seen war and conflict and the displacement of millions of people, partially due to exacerbated environmental conditions and worsening environmental conditions brought upon by climate change. And so, yeah.
Yeah, it's interesting because so what you're describing, I'd never realized that. So that's 2 major political events, right? That it's almost like the climate change was like the kindling, and then once the spark took hold, then it was directed, for political causes, I guess.
The Department of Defense has, for the last 20-something years, said about climate change that it is an accelerant to instability. And so it doesn't necessarily directly cause instability, and it doesn't necessarily cause war in a direct fashion. But certainly climate change and the effects of drought and maybe flooding or extreme weather events can certainly worsen social political conditions and economic conditions that can bring about competition for scarce resources and eventually conflict and war.
Okay. So, global climate change has been predicted by many different sources to lead to events. You mentioned droughts, right? Crop failures, famine, rising sea levels, flooding. I mean, lots of different extreme weather and weather change events. Those can lead to mass migrations and further exacerbate political instability. Are you beginning to see data to support those predictions as well?
There is, and there are many cases around the world where certainly climate and economic instability and conflict are at play. Another example here is Central America and the migrant crisis that is coming up to the United States southern border, Texas and so forth. Specifically, Guatemalans, Nicaraguans, and Hondurans, they are experiencing for the last few years a mega drought. And that drought itself is also exacerbated and worsened by climate change. And that drought is propagating, again, food insecurity, water insecurity. And what you see is MS-13 and other groups take advantage of those scarce resources. And in a nutshell, what happens is they end up controlling those vital resources, and they say to people, you either join us or you you fight and you die. And if you join us, you'll be able to have access to the resources that we have. And so a result of that food insecurity, that political and socioeconomic unrest, combined with violence and threats, has definitely pushed people towards migrating from their homes in Central America through Mexico to the United States.
Oh, okay. So again, it's what you're describing as an accelerant, right? Where other causes kind of dovetail into it and pick that up and use it, right? But yeah, so it
That's right.
accelerates existing instability. Well,
Exactly.
so in terms of data modeling, I wanted to get onto that. Let me start out actually by asking what organizations, because you mentioned a number, right? You had NASA, NOAA, USGS, NGA, USSF. I'm sure there are others. Which of these organizations produce the best data for analysis? I'm wondering if you have kind of a go-to source for reliable climate data, right? Like maybe NOAA is kind of the baseline that provides kind of the best, most consistent data, and then you fill in the blanks from other sources. Is that kind of how it works? Or?
That's a great question, and there is no simple answer to it because the specific needs of the user can depend a lot on the specific question that they're asking. And so, as you mentioned, there are so many different agencies and sources of incredible data. So the USDA, for example, they provide incredible data on crop availability, on agricultural yields, on vegetative production around the world. And those data sets are incredibly useful for things like estimating food security. You can also couple that with atmospheric data that's provided by NOAA to estimate precipitation and all kinds of effects from that. So it totally depends on the specific question, and there's no simple answer of, oh, you just got to go to this one agency and go to its data download page and there you go. And that does make it very confusing for new users. Where do they go to find the right data that they need? But more broadly, I would say that NOAA provides operational data for weather monitoring purposes. NASA provides research-based data, and so it might be specifically tailored to maybe a certain particular area or type of land or water that they're looking at. USDA might collate a variety of different data to be able to produce higher end products that are, for example, providing crop yield estimates around the world. USGS, US Geological Survey, they provide an incredible amount of data on terrestrial systems, land-based systems. So yeah, it totally depends on the question, but I don't personally have any particular go-to agency. I try to go to them all.
Oh, okay. And so once you get this data, then you get into the data modeling part of it. Now, I'm wondering, and I know this is an area where there are a lot of advances, right? You'd mentioned AI and a lot of just advances in computer technology. Have they played a large role in predictive analysis based on the data that's collected?
Artificial intelligence and machine learning is used every single day to bring the weather forecast that we have on our phones. And so absolutely, the modeling and predictive capabilities are being used all the time to be able to forecast extreme weather events and forecast real-time weather, in addition to forecasting and predicting medium to long-term changes as well.
Oh, okay. Well, now for extreme weather conditions, right? Like hurricanes and things like that. And again, global climate change seems to be exacerbating these. From that perspective, does the destructive potential of these types of weather events, does this get handled differently in terms of the data, in terms of the speed of processing, things like that, than longer term needs that might not have as much immediate impact?
Yeah, so the confidence level of these estimates and these forecasts certainly decreases as the time horizon, goes out further and further. And so, absolutely. So, estimating and forecasting, tomorrow's weather is going to be significantly easier than it is to forecast the climate conditions of a region 5 years from now. But at the same time, scientists have a number of different tools to be able to estimate that. And furthermore, the amount of data and the forecasting abilities that meteorologists have today is significantly better than what they had just 20, 30 years ago. So maybe a 5-day forecast 30 years ago would be 75% confident. It's 75% chance of being correct. Now that 5-day forecast has a 90% chance of being correct. So absolutely the ability to predict and forecast is increasing, and that's just going to continue as we continue to get further data, more data, and different kinds of data that is provided by these incredible sensors in space and also terrestrial based systems as well.
Okay. Well, so let me change topic a little, just a little bit, but and this was kind of a personal question because I've been following the SOHO satellites. These are the ones that monitor the sun. I've been following these online for years and years and years. I think they first went up in 1995. And from what I understand, solar output also has an effect on weather. I'm wondering, is that something that you also look at? Do you look at the SOHO data at all, and do you cross correlate that to, in addition to the Earth facing observations and data that you get on a daily basis?
Yeah, that's a good question. Global climate models, GCMs, they're referred to as, absolutely take into account solar variability and fluctuations of the radiation that is coming from the sun. And as you mentioned, SOHO satellites, there's also space weather satellites that are provided by NOAA, and they work in tandem with the Department of Defense. And that space-based weather data is certainly also used in these global climate models as well.
Okay. Well, so, I'm starting to round the bend on the questions here, but what are some of the advances and changes that you're looking forward to in this area in the future? Again, going out a little bit further. Do you think things like cost reductions or tech advances, do you see any upsets coming, and where are things headed in space-based remote sensing?
I'm really hoping to see further increase and ease of access to download and use the data that is provided by these agencies. Because currently it is difficult for a new GIS user to be able to understand how to bring down the data from NOAA or NASA or USGS. Those agencies have different portals. The file types can be often very confusing and very different from each other. And so the user instructions and again, ease of use can certainly be improved. And we're already starting to see that take place in those agencies. And then further GIS, new innovations in GIS and geographic information systems. So the software is definitely an area for innovation to occur. One example, Omnisci, They provide an incredible tool for users to be able to interpret and download data in a very easy to understand way. So before, maybe 5-10 years ago, these software tools would be extremely confusing. And, those software tools are becoming more widely used, and thus there's more money available to those companies to be able to improve the visualization and usability of the data. So that's what I'm really looking forward to.
Okay. Well, David, let me close. First of all, let me thank you again for your time. But let me close by asking, what comes next for you in terms of your research focus and your career path? Where are you going, and where do you see yourself in the next 5 years?
So I currently serve as a membership lead for a group and community of interest within DoD called RECESS, Resource Competition, Environmental Security, and Stability. And this group has been a real great example and path for me to work on these issues of environmental security and learn from others in this field.